Good morning, good evening, good afternoon. Today we are continuing the Compton Scattering. This is the part 2 of the series experiment that Compton did. Here, let's take the source of X-rays, that is molybdenum 42 X-rays. This is the source we have, and its wavelength is 0.079 nanometer. Further, we placed a graphite foil above the source. Let's say the photons are going like this, and they are observed at different angles. There are detectors at different angles. Like, let's suppose it to be here, this angle, let it be theta is equal to 90 degree, because in 90 degree we had the Compton shift. If you remember from the last video, we have seen this formula: delta lambda is equal to h upon mec into 1 minus cos theta. Now this we can rewrite as Compton's wavelength, because h upon mec is the Compton's wavelength. When theta is equal to 90, it would become cos 90, and the value of cos 90 is 0. So we put minus 0. 1 minus 0 is 1, and multiply, so we remove this. So we get that delta lambda is equal to the Compton wavelength. Now let's plot a graph for Compton shift. Now if we take the y-axis as the intensity of X-rays and the x-axis as the wavelength, at 90 degrees we will get a graph like where this is the initial wavelength and this is the final wavelength. The initial wavelength was the wavelength of molybdenum atom, so it was 0.079 nanometer, and the final wavelength will be 0.731 nanometer. And now if we take out the delta lambda, it would be 31 minus 9, 22. So it will be 0.0022 nanometers, and the Compton wavelength is 0.00243 nanometers. You can see that this and this is like really close. By the formula we had got that delta lambda is equal to lambda c. So we can say that the distance between this peak and this peak is approximately the Compton wavelength. From this graph we have two peaks. The first peak is the unscattered photons that have the original shorter wavelength and high energy. Its energy was like the initial wavelength's energy was this, or 17.49 keV. This is high energy because the wavelength was short, and the second peak was the Compton scattered peaks, bigger wavelengths and less energy. So we can say that the detectors registers both the unscattered and the Compton scattered photons. That's it for today's video. Hope you liked it. See you next time.